Hey guys, it's Mr. Horszewski here, and I'm going to be doing a video on the notes for section 4.1, linear functions and their properties. In this video, I'm going to be introducing the definition of a linear function, as well as the average rate of change, and doing example 1. So I just want to let you know ahead of time that chapter 4 is another one of those short chapters in our course, just like chapter 2 was. The idea behind chapter 4 is that we're going to be looking at two types of functions, the first being, of course, the linear function. The other function is going to be the quadratic function. Now, chapter 4 is, in my opinion, shorter than a lot of the other chapters because this is kind of a primer for chapter 5, where we'll be looking at polynomial functions in great detail. And it just so turns out that both the linear and the quadratic function are special types of polynomial functions. So it's really neat that we'll be applying a lot of what we've been learning so far in the course to study both the linear and quadratic, but also neat because all of that stuff is going to translate nicely into chapter 5 when we look at polynomial functions. Alright, well, without further ado, I'm going to go ahead and give to you the definition of a linear function. Now, this definition is going to really surprise you. Of course, that's sarcasm right there. So here's what a linear function is defined as in our textbook. All right, f of x, of course, representing function notation, but the expression that's on the right-hand side of the equal sign is mx plus b. So that's why I was a little sarcastic about the definition being a little bit shocking or earth-shattering, because it should look very familiar to you. What this expression is, mx plus b, of course, that's the slope-intercept form of a line. If you think about it, f of x is notation that replaces the variable y, so another way of writing this is y equals mx plus b. So you might be wondering, why are we using f of x instead of the variable y? Well, of course, at this point in the course, the variable y is replaced by function notation, but that's only if the equation represents a function. Alright, so I just want to let you know that linear equations are functions in disguise because, as soon as we have values of m and b, if we choose a particular value of x and plug it into the equation y equals mx plus b, you're only going to get one output. So the linear equation satisfies the definition of a function in the sense that no matter what value of x you choose as your input, you're always going to get exactly one output. Therefore, a linear equation is also a linear function. All right. So in this section, though, we are only going to be working primarily with the slope-intercept form of a linear function. So that takes us to the next definition, which is the average rate of change. So this is verbiage you're going to see every now and then in the homework problems asking to describe or provide the average rate of change. I just want to let you know that that's nothing more than the slope of the line, which of course is also known as, in a formula format, y2 minus y1 all over x2 minus x1. And of course, this is also known as, another definition from chapter 2, that is, delta y over delta x. Alright, of course we could also include some other versions of slope, such as rise over run, but this will be good enough for purposes of this section. So there we have it, the definition of a linear function, as well as the average